Okay, so we got cut off before. We just started to talk about the division property of square roots, which is a whole lot like the multiplication property of square roots. And a quick reminder from the last video that the multiplication property says if you have two things being multiplied inside of a square root, then you can separate them into individual square roots and multiply them. The division property is the same thing. If you have a fraction, if you have two things being divided inside of a square root, remember that part of simplifying a radical or simplifying a square root is you can't have a fraction inside of that radical. So we can split this fraction, this division, up the same way we did with the multiplication. Make individual square roots and divide them. Okay? So the square root of a over b is the same thing as the square root of a divided by the square root of b. So, for example here, if we have the square root of 36 over 49, then we can split this up into the square root of 36 over the square root of 49, and the square root of 36 is 6, and the square root of 49 is 7, so we get 6 over 7. Okay, so quick practice here, we have the square root of 144 over 9. The division property says that we can split these up into individual square roots and go 12 over 3, divide that out, and get 4. Okay, so that's simplified. Now, what you're going to find in through these next examples is that sometimes it's better to reduce that fraction first and then split it into two square roots. And sometimes it's going to be better to just go ahead and split into two square roots and simplify from there. The only thing that will tell you when to do which method, which approach, is just going to be some experience and just playing around a little bit with whatever it is you're trying to reduce. Okay? So, let's take a look at some. Now we've got the square root of 36a over 4a to the third. Okay? Now, for this one, I'm going to reduce the fraction first. Okay? That's perfectly fine. We can reduce 36 divided by 4 actually reduces to just 9 in the numerator. And then your a's, subtract the exponents. 1 minus 3 is negative 2. Since it's negative, we're going to drop the a squared into the denominator, so now we have the square root of 9 over a squared. Now we can split that up into the square root of 9 over the square root of a squared and simplify this a little bit easier. The square root of 9 is 3. The square root of a squared is a. And so we're done. Okay? So like I said, sometimes it's a little bit easier to simplify first. Okay? What about this guy? Well, if you look inside the radical here, there's nothing to simplify. So you really don't have that choice here. So instead, we're just going to go ahead and split this up into the square root of 25 y squared over the square root of x squared. And then we're going to just do our square root simplifying them. Right? We can use the multiplication property in the numerator. Well, in the denominator, the square root of x squared is just x. In the numerator, we get the square root of 25 times the square root of y squared. Where the square root of 25 is 5, the square root of y squared is y, so we get 5y over x. Okay? Think you might have the hang of it? Good. Because there's one more thing here, and that is the last piece of simplifying is that you can't have a radical in the denominator. So if we have a fraction, so let's say that this was actually the square root of 3 over 7 initially. And then you split it up into the square root of 3 over the square root of 7. But you can't take the square root of 7, not and get a whole number, right? So, but we still want to leave this in radical form to be as accurate as we possibly can. So then what do we do? Well, let me ask you this. First of all, go to a simpler example. 1/2. if I have a fraction like 1/2, I can multiply the denominator and the numerator by the exact same number and get an equivalent fraction, right? 1/2 and 2/4 have the exact same value. It's just, they just look different, right? That's the idea behind what we call rationalizing the denominator. We can multiply the numerator and the denominator by anything we want. As long as it's the same, then our fraction's going to stay the same. So we choose to multiply with a little bit of strategy here. So instead of multiplying by 2, like we did for the 1/2 over there, we can multiply the numerator and the denominator by the square root of 7. Okay, we're still multiplying by the same thing in the numerator and the denominator, which means we're multiplying by 1, which means we're not really changing the fraction, we're just changing how it looks. So what happens if you multiply by the exact same radical that's in the denominator? Well, when you multiply fractions, you always multiply straight across. So we're going to multiply the square root of 7 times the square root of 7. Remember that we multiply the insides and multiply the outsides. Well, there's nothing to worry about multiplying the outsides too. So we multiply the insides, and the square root of, 7 times 7 is 49, so we get the square root of 49 in the denominator. In the numerator, we take 3 times 7, and we get the square root of 21. Now we can try to simplify. And we know that the square root of 49 is 7, and we can't simplify the square root of 21 because there's no perfect square number that goes into 21, and so we're done. So why did we multiply the denominator and the numerator by the exact same radical that was in the denominator originally? In other words, why did we multiply by the square root of 7 over the square root of 7? Well, because as you see, when we do that, we eliminate the radical in the denominator. The square root of 7 times the square root of 7 will give you just 7. And you can see why here. We multiply and get the square root of 49. The square root of 49 is 7. Okay? So, simply put, we want to multiply by the exact same radical that's in the denominator into the numerator and the denominator both. Okay? So, can't have a radical in the denominator. So what are we going to multiply the numerator and the denominator by? Right? We're going to change our fraction. We're going to multiply by the exact same thing in the numerator and the denominator. What are we going to choose? Well, we can choose anything we want, right? So I'm going to choose the square root of 5. I'm going to choose the exact same radical that's in the denominator. And why is that? Because when I multiply, so I'm going to take 7 times, well, there's nothing else outside, so it's just 7. And then inside and inside, there's nothing else inside of a radical except for 5. So we get 7 radical 5. Over, inside times inside is the square root of 25 in the denominator. So we get 7 square root of 5 over the square root of 25 is 5. And so we're left with this, 7 square root of 5 over 5. And that's perfectly fine because there's no radical in the denominator. There's no perfect square number that will divide into 5. And so we are simplifying. Okay? Now, look at number 6. First of all, what's the problem? Is this simplified? The answer is no, it's not simplified. Why not? Because you have a radical in the denominator. How do we get it out of there? We're going to multiply the numerator and the denominator by, you guessed it, the square root of 3. By the exact same radical in the denominator. So we go 2 times 3 because they're both inside and get 6. 3 times 3 because they're both inside, we get 9. So we get the square root of 6 over the square root of 9 is 3, and we're done. Okay? All right, now you try. Try this guy. Stop the video, start it back up, and see how you do. And did you get 5 square root of 4m over 4m? Okay, I'll walk you through it really quick. We're going to multiply the numerator and the denominator by the square root of 4m because that's the radical in our denominator. When we do that, 5's on the outside. So in the numerator, we've got 5 outside the radical. We've got 4m inside the radical. Everybody stays where they are. So 5 square root of 4m is what we end up with here. In the denominator, you've got 4m times 4m inside the radical. 4 times 4 is 16. M times m is m squared. So we get the square root of 16m squared. The multiplication property says we can split those two, the square root of 16 into the square root of 16 times the square root of m squared. Square root of 16 is 4. The square root of m squared is m. So now we're here. And so we're left with 5 times the square root of 4m all over 4m. And that's how we end up there. Okay? Make sense? I hope so. Got one more to try here. Simplify this. Stop the video, start it back up, and see how you do. Okay, square root of 21x over 3 is what you should end up with. All right, again, walk you through it real quick. The square root of 7x over 3, we can split that into individual radicals in a fraction. So the square root of 7x over the square root of 3 here. Then to get the radical out of the denominator, we're going to multiply by the numerator, but multiply by radical 3 into the numerator and to the denominator. So 7x times 3 is 21x. Those are both inside the radical, so we multiply them. 3 times 3 is 9, so we get the square root of 9. The square root of 9 is 3, so that's how we end up with the square root of 21x over 3. Okay? Hopefully that makes enough sense. If not, make sure you come find me, Star, before or after class, before or after school, and we'll go through it some more. Okay? Homework's out in Canvas. Make sure you have that done for next time.